Hi folks, welcome back. So on this channel and on my blog and other places, I've been talking about specialized harnesses and quote unquote compilers for specialized harnesses. And the larger point I'm trying to make is that you don't want to use a fully dynamic, fully general purpose reasoning planning agent like Claude Code or Codex for every possible task. And I've offered some ways to go about building these specialized harnesses. I'll link to some of those videos below. This paper is also proposing something along very similar lines. So the motivation in this paper is pretty much identical to my own motivation for this problem. However, it is offering a slightly different approach to solving the problem. I love this word crystallization because that's exactly what it's doing. So let's take a closer look. This paper came out the day before yesterday from Arun Malik at Microsoft. And the point the author is trying to make over here is that every time you try to solve a problem with an agent, when it solves that problem successfully, the next occurrence of that same problem is rerunning the agent from scratch. It's doing all that reasoning, planning, investigation, all that stuff it's doing from scratch again. It's as if, if I wanted to travel between two cities, building a new freeway between those two cities every time I wanted to travel. And of course, this uses up a lot of tokens every time the agent tries to solve this problem from scratch. So the intuition behind it is very simple. You have a powerful agent solve your problem from scratch one time. You see what it did, you look at the traces, and then every future invocation of solving that same problem should use that crystallized or that extracted trace rather than solving the problem from scratch. The core way to conceptualize this is to have a taxonomy of the types of executions when your agent is solving a task. So you start with what the author here is calling type 3, which is using a full general purpose agent. So you have sub agents, you have reasoning, planning, all that stuff. And of course, this uses a lot of tokens and it's not deterministic in that you might get slightly different executions every time you run it. Type 2 is what the author is calling a hybrid, where you have extracted some structured steps. You're still calling LLMs for some tasks that absolutely do require LLMs. And now you're saving some tokens because you're not doing as much reasoning and planning as you were before when you were doing a fully agent orchestrated execution. And finally, sometimes you can go all the way up to what the author here calls type 1, where you can look at your type 2 hybrid traces and actually convert the entire task into fully deterministic code. And in that case, you're not calling LLMs at all. There are no tokens. Now, the question is, how do you go from type 3 to type 2 to type 1? And here the paper is a little light on details, but spells out some transition requirements in that you're going to look at your type 3 traces, and if it's had more than a certain number of successful runs, you'll try to reflect and extract some structured steps and promote it to type 2. And then once that workflow is elevated to type 2, you'll do the same thing. You're going to look and see if it's had a number of successful runs and then try to see with some reflection whether that type 2 flow can be further elevated to type 1. And of course, as expected, this works out to be economically very beneficial because as you go from fully dynamic to hybrid to deterministic, you save a lot of tokens and the cost of executing that task goes down. I thought this diagram was really interesting because what this is showing is that as time progresses and you crystallize more and more of your workflows into type 2 and type 1 flows, which are the hybrid and deterministic ones, you can see how you're taking away share from this red part of the diagram, which is using a fully deterministic agent. And so over time, you can reflect on your traces, your agent executions, and try to extract these more deterministic or more hybrid workflows that are a mix of deterministic code and LLM calls where you absolutely need them. So yeah, I thought this was a very timely paper. I think this is the direction in which agent building and harness engineering is really going to go as the field matures. I hope you enjoyed that. If you like content like this, consider subscribing, like the video, and I will see you in the next one.